Okay, so we have a pathway problem. This is a very famous pathway problem that shows up in permutation combination type of questions. So we have this pathway that you can see is a grid. We want to go from point A to point B, and the only restriction is that you have to move to the right and or down to get to point B. We want to know how many possible pathways we can have or we can use to go from point A to point B. Now, solution to come up with this. So from point A, we're looking at moving to the right and down. So one pathway will be going this way, and I'm marking it right now. So that's one way to the right and then coming down. So that would be one. And then the next one will be down the other way, down the bottom, and goes to the right. So notice that there will be so many of these, but we want to know how many, the fastest possible way we can come up with a solution. And here's how you can do this. So from point A to go to this junction, there's only one way to get here. From here to here is only one way, from here to here to one way, and then to the end one way. And also you notice that coming down, one way coming down from this point to this point is another one way and just one way. Now to get to this point right there, there's one way coming this way, one way coming the top, so that would be two. From this point, there's one way coming this way. There are two possible ways. Remember, we just talked about that. So there will be three ways. And then notice that the next one will be four. So four ways this way, one way coming down from the top. There's five ways to get to that point. Now notice that we can do this. So this would be three way this way, three way coming down. That would be six way this way, four way this way. That would be 10, 15. And then this one would be 4, 10, 20. And you'll notice that together there's 15 way coming to the point B from the top, 20 ways coming from the bottom, the horizontal. So the total number will be 35. All right. So that's the maximum number of possible pathways that you could have to go from point A to point B. So the interesting thing about this is that this is a pattern that has been based on a very famous pattern. It's called Pascal triangles. Okay, and notice that that's exactly what's happening. 1 and 1, that gives you 2. 2 and 1, that gives you 3. 3 and 1 will give you 4, and so forth and so on. And the Pascal triangle is exactly based on that. You start from the top 1, and then you go 1, 1. Then each one will be added. So these two will add, will give you 2 in the middle. Then 1 again. But these two will add, will give you 3. These two will add, will give you 3. And then 1 comes down again. And so forth and so on. And notice that I can keep doing this for as many terms as I can. I can go down this pyramid as far as I possibly can and we can have so many different variation up to the 1 billions or trillions or infinitely many terms. And obviously there's another application to this, is binomial expansion they can use at a higher level, but that is the basis for the pathway problems. That's another way of looking at it.